All right. So we're going to look at how do we solve quadratic inequalities. So how do we solve quadratic inequalities using just a graph? All right. Well, here I have x squared minus 4 graphed on two different graphs. But we're going to look at the difference in the solutions between x squared minus 4 is greater than or equal to 0 versus less than or equal to 0. Now, if it was just x squared minus 4 equals 0, my solutions would just be 2 and negative 2. But since these are inequalities, they have whole sets of solutions for the x's. Okay, so this very first example, x squared minus 4 is greater than or equal to 0. What I have to look at is where on the graph is this graph greater than or equal to 0 as far as the y's go. So if I look, here's where y equals 0, the x-axis. So if I'm looking for greater than or equal to 0, I'm like, okay, where's the graph above the x-axis? Well, it would be for all of these x's and all of these x's. Right? If you were to plug in 5, you would get a point on this graph way up high, and it would be above the x-axis. So my solution here would be all of the x's that are less than or equal to negative 2, or all of the x's greater than or equal to 2. Now the next case, here I'm looking for all of x squared minus 4 that is less than or equal to 0. So which part of this graph is below the x-axis? Well, right here. Well, what x values are those? These x values. And these x values, I can say, are between negative 2 and 2. So negative 2 is less than or equal to x, and x is less than or equal to 2. Alright, so we're going to solve 3x squared plus 4x plus 1 is greater than or equal to 0 by graphing. To do this, we're just going to find the x-intercepts of this inequality. And those x-intercepts are called the critical values. And then we'll just look at the shape of the graph to see if it's above or below x-axis at certain times. Alright. So 3x squared plus 4x plus 1. To solve that, I can either factor or use the quadratic formula. This one can be factored, so let's go ahead and factor it. Let's see, 3x squared plus 4x plus 1. If I want to factor this, I'm going to have to use slide and divide because there's a number in front of x squared. The coefficient of x squared is greater than 1. So, multiplied into that 1, x squared plus 4x plus 3. What two numbers multiply to 3 and add to 4? 3 and 1, so x plus 1, x plus 3. And since I multiplied earlier that 3 times 1, now I have to divide out that 3. So this is, the 1/3 doesn't divide evenly, so it slides over. 3x plus 1 times 3 over 3 is 1, so x plus 1. Okay, from those factors, I can find my critical values by setting each of them equal to 0. So 3x plus 1 equals 0. X is going to equal negative 1 over 3. And for x plus 1, if I set that equal to 0, I get x equals negative 1. And honestly, the whole time I should have set this equal to 0. So that way at the end we could solve for our x-intercepts, which were our new critical values. Okay, so let's plot what those x-intercepts would look like on a graph. So since these two things are pretty close to each other, negative 1/3 and negative 1, we're going to zoom in quite a bit. So we have this graph, and we'll count. Like here's negative 1. This will be negative 2. Okay. let's plot this these two x-intercepts. So I know at -1 I have an x-intercept, and at 1/3. Now to actually graph this, I would have to find the vertex using x equals opposite b over 2a, but that's not what we're trying to do. We're just trying to solve it using that graph. So all I really have to know is which way does this graph open? Like, it opens up because it's a positive graph, right? This 3 is positive, so it opens up. Is it a solid or a dashed inequality? Solid. It's solid. Why? Greater than or equal to. So if I know that it opens up, I know that the vertex is somewhere down there, and it does this. Like, it's going to pass through both of those x-intercepts and finish on both sides going up. So now I just say, okay, where are the values greater than or equal to 0? So where is this graph above the x-axis? In these little arms right here, right? These are both above the x-axis, and these go forever to the left and forever to the right. So it's a split situation. This is an OR. So it's all of the x's that are less than or equal to -1, or the x's that are greater than or equal to -1/3. And that's the solution to that inequality. Okay, so let's solve -2x squared minus 8x is greater than or equal to 0. So my first step is I'm going to set that equal to 0. And I say, can I factor this? Well, these two things have common terms. I can factor out a -2 and what else? X. So I can say, okay, -2x, and I'd be left with x plus 4. Okay, once we factored, we set each of those things equal to 0. And find my critical values. So x equals 0 and x equals -4. These will be the x-intercepts that I plot on my graph. So I draw my graph. 1, 2, 3, 4. It's or equal to, so these will both be solid at 0 and -4. Which way does this graph open? Down. It opens down. Why do you know it opens down? Because it's negative. So the vertex is going to be above these 2 points, right? So I can draw it like this. Now sure, that might not be exactly what that graph looks like, but I know that the vertex was somewhere above those 2 points and it opens down, so we're okay. Now, where are the x values greater than or equal to 0? So all of these points are above the x-axis, right? So all of these x values will give me a value that's greater than or equal to 0, since all of this was above the x-axis. So all of the x values are together, so is this an and or an or situation? And. Right. So my answer would be all of the values between -4 and 0. So -4 is less than or equal to x, and all of these x's are less than or equal to 0. The last one we're going to look at is 2x squared plus x minus 4 is less than or equal to 0. So we would always try to factor first. I'm going to go ahead and let you know this one cannot be factored. So I'm going to have to use the quadratic formula. Okay, so I set these things equal to 0. 2x squared plus x minus 4 equals 0. If I'm going to use the quadratic formula, I need to know what my values are. What's a equal? 2. B equals? 4. And c equals -4. Okay, so I'm plugging all of this into x equals the opposite of b plus or minus the square root of b squared minus 4ac, and this is all of it is divided by 2a. So x equals -1 plus or minus the square root of 1 squared, which is 1, minus 4 times 2 times -4, all over 2 times 2. I'll even write that little squared so we can look back at it later. Okay, so this is x equals -1 plus or minus the square root of 33 all over 4. Okay, so since we're actually just trying to find the x-intercepts, we can use decimals and just approximate. So we can do x is equal to -1 plus the square root of 33 over 4, and x is equal to -1 minus the square root of 33 over 4. So we have to split up the plus and minus because I have two different x-intercepts. They'd be at 1.19 and and these are approximations. We're rounding a little bit. -1.69. All right, plot those on a graph. At 1.19, that's just past +1. And -1.69 would be over here somewhere. We can label those. This is 1.19, -1.69. Okay, this graph is going to open up. So the vertex is above or below these points? Below. The vertex is below. So somewhere in the middle of these two things is the vertex, and it opens up through these points. Oop, I missed a little bit. I'll just make this dot bigger. It's a solid graph because it was or equal to. Now I'm looking for all of the values that are less than or equal to 0. So again, this is where y equals 0. I'm looking for all of the places that it is less than that. So do I look above or below this line? I look below. So all of these values are below 0. Now my answer is only going to concern the x's, right? So I can highlight these x's give me y values that are below 0. So my answer would be -1.69 is less than or equal to x, and x is less than or equal to 1.19.